So this lesson is over the quadratic formula. Obviously, quadratic formula is only when you can use it on quadratic. So most are set up this way, where we have ax squared plus bx plus c. And that's the reason I do that. That's where you get your a, b, and c. It's got to be equal to 0 because we're solving. Again, the a is always with the x squared, the b is always with the x, and the c is always the constant that doesn't have a variable with it. The reason I say that is it doesn't show up very often, but occasionally you'll get one where they have the order mixed around where the x squared comes second. I personally would always put it in this order, but as long as you know it's not the a is the first number necessarily, it's the a always goes with the x squared. Now again, the vast majority of the time it's going to be the first number, probably all the time when we just in case. So once you have the quadratic equation, x squared plus bx plus c, you can plug it into the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac over 2 times a. I will not expect you to memorize that. I will probably have you add it to your cheat sheet. Actually, on one of our review days, I'll be tempted to print off a new cheat sheet for you that has factor by grouping and has that formula on there, just to make sure you guys have that for the test. One big thing with this that I always like to make sure I point out, remember when we factor, we always get 2 answers, or almost always. We still get 2 answers with this. That's what the plus or minus is. So one way you do this equation, you use the plus sign. One way you do this equation, you use the minus sign. And that's how you get your 2 different answers for this. The good news with this, a lot of people hate the quadratic formula. They'd rather factor. The thing is that not everything can factor, but every one of them you can use the quadratic formula. Because factoring only works when you don't have any decimals or any fractions, really. Or I guess you do get some decimals or fractions that are just really nice decimals or fractions. This one you can use where you get imaginary numbers, you can get repeating decimals. So the quadratic formula works for every quadratic, not just the ones that can be factored. So a couple important notes. It has to be equal to 0. That's the main thing. When you're solving, it's got to be equal to 0. The 4 and the 2 are always there. So I've had people that ask me several times, where does the 4, where does the 2 come from? That's part of the equation. It's always there. It's always a 4. It's always a 2. Make sure you follow the order of operation and use your calculator and use parentheses. So most of this part we're going to do in a calculator. Technically, especially with the calculators nowadays where you can type in fractions, you could actually type the whole thing in your calculator in one step. If you want to do that, you can. I'm going to tell you to avoid that just because I think if you take 2 or 3 steps, you just are entering less in your calculator. And putting the whole thing in your calculator is a lot of work, and there's a lot of little mistakes you can make. So we'll do this in our calculator, just not all in one step. Last thing, make sure you double check that you plug in the right numbers and that you have positives and negatives that are correct, because that's a big thing that'll hurt you, using the positives and negatives. The other thing I will say personally, I know a lot of people come into this and they hate the quadratic formula, and I don't understand why I get so much hate. The only thing I can guess is that I don't know how many years you've done the quadratic formula, but when you first learned it, it was probably a really big, intimidating formula. But now that you've done a lot of other stuff for Algebra 2, I'm hoping this is it's another thing where you're just plugging numbers in, then using your calculator. So don't be intimidated. Make sure you're looking at this semi with an open mind. And like I said, I don't think it'll be as bad as some of you guys remember it being. So you do not have to do this on every problem, but I have my A, B, and C. I think it's nice. Or some people just write it on top, A, B, and C, whatever you want to do. But it's kind of nice to have that label. Actually, right now, like I have it, is if you just label A on top, a lot of students plug the x squared in as well, but A is just a 2. If you just put the B on top or the A on top, you have to remember that the positive or negative goes with it. So this is positive 11. People that do it that way and they end up missing their positive and negative. But again, if I were you guys, especially what you do, I would go ahead and want the A, B, and C. If you feel you're confident, that's up to you. An extra second, it does kind of help you guys get processed a little bit. And again, it's equal. That's the reason we can do that. We have to get it equal to 0 first. So the way I do this, I will tell you, it's a lot of writing, And it's a lot of calculator work. You do not have to do a lot of work in your head. And if you are, I would avoid it. So, the formula you guys have is negative b plus or minus square root of b squared minus 4ac over 2 times a. So the first thing I do is I literally just plug those numbers in, and I don't do any simplifying. That's a lot of students miss this because they try to simplify it while they're plugging it in, skip a step, and you should not skip this step. So it's negative b, so it's negative, b is 11. I always use parentheses when I plug these numbers in. It's the square root of b squared, so 11 squared. It's 4 times a is 2, under c is 12, over 4 times your a is 2. Technically, it's x is equal to, but if you put that, that's fine. So again, that's my first step. I list everything out, and literally everything I plugged in, every time I plugged in a letter, I always used parentheses. That's going to help you. Yes. So you'll have to do it twice. You'll do it once with plus and then once with minus. Yeah, there's not a plus or minus in your calculator because it means two different things. It's just a way that you can do it without writing out the whole thing twice. So we'll get there. So that's the first step. My second step, I always call, is cleaning up shop. You're just simplifying things that you can. So again, there's several different. Like I said, you can type that whole thing in the calculator. Obviously, you'd have to once with the plus sign, once with the minus. But if I were you, I'd take it in chunks. So the first thing I do is negative 11. I just write negative 11 since it's a parentheses, plus or minus. Is 2, so I make that 8. And then I simplify. The hardest part is everything square root. Now, I do not take that square root yet. That's going to be the next step. But you need to simplify everything inside that square root. Now, again, some of you are going to try to do this in your head. 11 squared is 121 minus 4 times 2. Don't even worry about it. I type that in my calculator, and I literally type out exactly how I see it. So I type out shorter ways to do this, but this way you don't have to think at all. A parenthesis, then 11, then parenthesis, squared. Minus 4, parenthesis, 2, parenthesis, parenthesis, 12, parenthesis. I literally type in all those parentheses, and I hit enter. That ends up giving me 25. Now, the reason parentheses for everything is that this, what we plugged in was a negative 11. There's a difference between, if you type in negative 11 squared, that's going to give you a different answer than negative 11 squared. I'm not going to go into the detail right now, but that's why I always use parentheses, and that's, again, a huge part of it. So we cleaned everything up a little bit so it looks a little bit nicer. Now I simplify that square root. Some of these you will not be able to simplify, and those are actually the quicker ones, and we'll talk about that in a second. Being negative plus or minus the square root of 25 is 5 over 8. Now again, the plus and minus, I've still kept it as just one big formula. This is where I split it up into two. The only other way you can simplify is taking the negative 11 plus 5 and then 11 minus 5. So again, you do not have to do it this way, but the way I always like to do this, I draw two branches. Again, you don't actually have to do that. It's just kind of a good way to visualize that. And one of them is the plus sign, negative 11 plus 5 over 8. And the other one is the minus sign, negative 11 minus 5 over 8. Now, again, from here, not a bad idea to use your calculator. Just again, it's kind of hard because we never had, when I was in high school, we never had a fraction button on a calculator. We had to use division. And my calculator right away. Or if you do, you have to use parentheses. Since you guys have a fraction button, you can do that. Negative 11 plus 5 in the numerator, 8 in the denominator, hit enter, that's fine. However, again, the concept, negative 11 plus 5 is negative 6, so we have negative 6 over 8. Negative 11 minus 5 is negative 16 over 8. And then you simplify these, or you could put a decimal. If you wanted to do the decimal, negative 6 divided by 8, you can. That ends up, if you divide both by 2, is negative 3 over 4. So that'd be negative 0.75 if you use the decimal. So that's one answer. Negative 16 over 8 is negative 2. That's your second answer. Those two answers of that. Now again, here's the funny thing. We're going to learn problems that the square root of 25 was really nice and just ended up 5. I know it's really nice because you don't have a lot of fractions and decimals to deal with until the very end. But actually, we're done with today. I hope you don't like those because you have to do like 10 extra steps. If we were able to reduce that square root, I'll show you that here in a second. I think, I don't remember which one. One of these. I forget if number 2 is like that or not. Yes. Right here. So this 4 is, was 2 times 8. I'm going to show you 2. Yes, thank you. Yeah, so that it should be 2 times a. I knew I should have looked at my formula. So 2 times a, so that's just going to change. The good news is that just changes the denominator in these. So hopefully a fairly quick fix. So that's 4, 4. So negative 6 over 4 is negative 3 over 2, which again, if you want to make a decimal, is negative 1.5, I believe. And then negative 16 over 4 is negative 4. Thank you. Now that is the double-edged sword. You guys will have the quadratic formula, but you would not believe how many students still mess that up. I have students that just literally forget the square root symbol. A very common one is the first is a negative b. A lot of people forget that negative. Check the formula, quadratic formula. Again, I'm going to give that to you on a test. There's no reason to memorize that, but that means you have to double check that. Anything else? All right. So moving on to number 2 then. So I'm just cleaning this up because I went a little bit overboard on the space. 2, again, personally, I would still list out my A, B, and C. Maybe I'll do it over here so I have a little bit more space. So my A is 4, my B, oh, before I do this, I need to get everything on one side. I need to get it equal to 0, so subtract 4. So we have 4x squared plus 8x plus 3 is equal to 0. So my A is 4, my B is 8, my C is 3. Again, it's got to be equal to 0 just like when we factor. Anytime we solve with quadratics, the methods we are using, it's got to be equal to 0. There's other methods where it doesn't have to be. We're not going to use those. So now we're plugging this in. X is equal to negative b. I'm going to run out of room. Plus or minus the square root of b squared minus 4 times a times c. Sorry, you can't read that. That's supposed to be a 4. Just trying to save on space. Over 2 times a. So that's my first step. And then again, my second step is cleaning things up a little bit. So that's negative 8. 8 in the denominator. Then we have the square root. And then again, inside the square root, I'm going to use my calculator every time. I know I'm not that great at mental math, but why risk it? So parenthesis 8 parenthesis squared minus 4 parenthesis 4 parenthesis 3 parenthesis is 16. Now I'll be honest with you guys. If you don't want to type these parentheses in over here, it's minus 4 multiplied by 4 multiplied by 3. You can do that. Even if it's a negative, your calculator will take that into consideration. Parentheses, because that way I can type it in exactly how I write it. And I think a lot of students that helps. We can reduce that, so I'm going to do that over here. Negative 8 plus or minus 4 over 8. Realize that the denominator is over the whole thing. Some people just put the we'll do it this way. Don't write this down because it's wrong. They'll just put the denominator over the square root. That denominator is the whole thing. So this goes into our two separate scenarios, -8 plus 4 over 8, -8 minus 4 over 8. -8 plus 4 is -4. Again, use a calculator if you need to. If I was making an answer key, I would probably put that in my calculator to double check. -1/2 or -0.5. Again, decimals or fractions, doesn't make any difference. -3 over 2 or -1.5 is the next one. -8 minus 4 is -12. Divide both of them by 4, you get 3 over 2. -3 over 2, which is -1.5. Any questions on those? And again, keep in mind, like I said, today we're going to do a little bit differently. For these two that you do on your own, after I give you a little bit of time, I'm going to start calling on some of you guys for answers. One other important thing I will tell you, I will not call on you to do one whole problem very often. If I do, because it's a really short problem, like I will that problem. So for problems like this, I'll probably call off, as far as I call each one of you guys on just number 3 and 4. All I do is I ask for one step. I don't make you do the whole thing for me. There's several reasons I do that, but hopefully that uses your mind a little bit. But again, keep that in mind while you're working on these. I'm going to call on some people. If you're somebody that works ahead, that's fine, but keep in mind, I'm going to call you on some of these. So if you work ahead, that's great. Just please realize you're calling back. Again, check your answers with people around you if you want, or if you're unsure. I do not have the answer of this. I probably should make an answer key, but it's never been our strong suit. And that first one, we ended up with -4 over 5 and -1. The second one, you ended up with 4 and -5 over 2, I believe. All right. So moving on to the next ones, and I'm going to talk about this a little bit. I put a little note that's more for me and you guys, but it says reduce radical. And we are going to learn something later called how to reduce a radical, and it's going to be terrible. No one's going to like it. No one does. I don't know why we have to do it, but we do. I love to skip it for me, but that's okay. So we're not going to worry about it now. So that's going to make your life a lot easier. Reducing radicals, no bueno. We're going to do this before. Everything on the side of the equation is the equal sign. For us, that's normal on the left-hand side, and it doesn't actually matter as long as it's equal. Then we're going to do the same thing with the A, B, and C. Again, if you need to list them, don't be afraid to. Your A is 9, your B, your C is 16. I have -4 squared minus 4 times -16 over 2 times A is 9. 4, so plus or minus 2, 18. Inside the square root, you have 4 squared minus 4 times 9 times -16. Again, I would encourage you guys to just put it in exactly how you see with the parentheses. You don't have to. There's other ways to do it. I'm just always scared that when you don't, you're going to miss some order of operation stuff. That ends up being 592. Now, the whole thing with 592, the other problem is when you did the square root of 169, it was 13. And if you didn't know what that was up in your head, you could type in your calculator. Square root of 169, it says 13. But if you do the square root of 592, that gives you a really weird decimal. For some of your calculators, that will do a reduced radical, so you'll have some number outside. It'll be like, I don't know, 4 root 10. I mean, it's not going to be that at all. But you have a number outside of a radical. If you want to use that number, you can. That's what I'm talking about, where later we'll learn how to do that. So if you want to use that in your calculator, you can. But for mine, I don't have to do that. Mine's just a decimal. If you get a decimal answer, that's all you're going to do to leave it. That's your answer. Now, again, you might say, well, Mr. Stephan, you said you have 2 answers. Well, yeah, technically, if you wanted to go into detail, you could say, well, we have one answer is -4 plus square root of 592 over 18, and one of them is -4 minus square root of 592 over 18. And some multiple choice questions will give you those. They'll separate it like that. But for me, why waste your time? That's what this means. I'm okay with you leaving it like that. these fractions, like the 4 and the 18, there's a way to reduce that. I'm not going to go over that now. Later, but again, for me, I have a certain goal that I want you guys to be able to achieve. That's the main thing. If you get to that part, even if you don't reduce it, you still get an answer. You can still work with that. You can still build your bridge and stuff, make your archways. So again, I personally like these better because you're done there. You don't have to split it into two and then do some more math and then reduce and then simplify. You don't do any of that. I got that as my answer. That square root doesn't reduce down at all, or doesn't work nice and evenly. Again, for this one, it actually does reduce, but we're not going to pay much attention to that yet. Any questions on that one? So number 6, I'm going to make myself a little more room here. Again, we need to add 10 to both sides. So we end up with 2x squared minus 7x minus 3 is equal to 0. And again, now I just need to plug those in. So x is equal to negative, my b is negative 7. Square root of negative 7 squared minus 4 times a times c over 2 times a. Now again, that negative 7 squared, I would always use parentheses for that part. Over here, if you want to use multiplication signs, you can, but this part, I would use parentheses because negative 7 squared is different than parentheses negative 7 squared. If you remember that any number squared is positive, then do it however you want. But a lot of people put negative 49 for that when they're putting it in. So this ends up being positive 7 over 4. And then inside the square root, we have negative 7 squared minus 4 times 2 times negative 3. Again, if you're not sure, put that in your calculator to make sure you don't get a nice whole number. If you don't, that gives you a decimal. Is your answer. Again, if you want to write it in two different answers, 7 plus square root of 73 over 4 and 7 minus square root of 73 over 4, you can. Certainly don't have to. The decimal, yeah, so if you get anything other than a whole number, so rather than putting your answer for this one as a decimal, just leave it like this. Take this radical again, I should do better. If you type in your calculator the square root of 12, it a lot of times spits out to you 2 square root of 3. I don't care which one you use. Later on, I'll show you how to get that answer, the 2 square root of 3. Which one you use. But I would leave that as a radical. I will not make it into a decimal. So if you got like the square root of 81, that is like the problems we just did before this. So if you get something that works out nice and evenly, please do so. Please do that and actually get your numbers and your fractions. But if you get something that gives you a decimal, stress, square root of 73. Again, your square root of 592, it does something like this, I think, when it reduces down. I don't know what it is. But that's all stuff we'll do later. So this 12 I just made up because I know how to reduce that one in my head. That doesn't have anything to do with our problem. But yeah, so if you do end up with a number that you can take the square root of, so if you end up with like 25 or 16 or 81 or 121 or 49 or 64, any of those perfect squares, then yes, please reduce it because it's a nice whole number for your radical. But these, you end up getting repeating decimals, or some of them are imaginary. We'll talk about that in a little bit. So go ahead, do number 7 and 8 on your own. Walk you guys through it quickly. So for number 9, first thing again, or sorry, number 8, add 9 to both sides. So we end with 4x squared plus 12x plus 9 is equal to 0. And then we go ahead and sub that in. So we have negative 12 plus or minus. I did it again. I'm not going to have enough space. 12 squared minus 4 times 4 times 9. That's a 4. Over 2 times your a is 4. So negative 12 plus or minus, it's going to be over 8. And then inside the square root is 12 squared minus 4 times 9. 0. So I threw this in there. I forgot that I did this because this kind of is going to help us out on some of the parts after this. But the square root of 0 is just 0. So this one, you actually do end up like the last ones, plus or minus 0 over 8. Well, whether you add 0 or subtract 0, it's the same, right? So this ends up being negative 12 over 8. And that we can reduce down. If you divide both by 4, you end up with negative 3 over 2, which is negative 1.5. I did this one. I only was going to have you guys do number 7. Totally forgot I did this, but go me, because clever. The reason I did this is because later we're going to talk about how do you know how many answers you're going to get. So far we've gotten 2 answers for every one of these. Sometimes, well, the time you get one answer is one like this, where you end up getting the square root of 0. When you get a square root of 0, that's what we talked about. When you add or subtract 0, it's not going to do what you did. So that's the rare occurrence where you actually only end up getting one answer for that. And we'll look at that with graphing Thursday, Friday as well. But if you end up getting the square root of 0, that only gives you one answer. Again, that'll come into play a little bit later. Any questions on either of those? So the next thing we're going to talk about is not on the test. So if you want to tone this out, it's up to you. I'm not going to go into depth. I'm going to go a little bit quickly through this. The other Algebra 2 classes don't talk about this until later, and so that's why it's not on the test. We'll do it a lot more in depth later. I wanted to mention this because I think it helps you understand a little bit of what we're going to do next. That is on the test. So I don't know if you've ever heard this, but they're all not imaginary numbers. They don't actually exist. The whole thing of imaginary numbers are all based on this mathematical philosophy. I take the square root of a negative number. And the reason, if you ever wonder, why can you not take the square root of a negative? Well, because the square root is the opposite of something squared. Well, if you plug in a positive number squared is a positive. If you plug in a negative number times a negative number, negative 2 times negative 2 is positive 4, so that's also positive. So the square root is the exact opposite. That's why, what is the square root of negative 16? Well, it's not positive 4, but it's not negative 4. There's no answer to that. So in math, for whatever reason, I can only assume to torture high school kids. And again, this is up to me. I would never touch this in high school at all. Because talk about something, if you told me where am I ever going to use this, I literally come up with a good answer. Because no one uses this. Maybe NASA, but I don't think that. The good news is, for right now, we're not going to go into too much depth. So the whole idea is that if you have the square root of a negative, you're going to end up and so they represent with the letter I. So the square root of negative 1 is I. That's it. Technically, the way we would do number 9 is you would flip it up. The square root of 144 is negative 1 times 144. And again, we'll talk about this a lot more when we do a lesson where we are reducing radicals. And then that square root of negative 1, and then the square root of 144 is 12, and then naturally you normally put it with the I back. That's great. That's fine. That's standard. The way we're going to, and again, not right now, is that's the way to explain it, and it's a little bit complicated. But really, all you need to remember is you cannot take the square root of a negative. If you ever have a negative, you just put I in there. So square root of 144 is 12. Negative 9 is 3. You can't take the square root of that. Well then, just like we talked about before, and you just have to put an I with it. And if there's a radical, you usually put the I first. Doesn't make any difference. So I put this problem, and the punchline is what you end up getting is you end up getting the square root of a negative number, and so all you need to do is put an I in there. So just really quickly, if you'd actually plug this in, we would have negative 4 plus or minus the square root of negative 4 squared minus 4 times 5 times 6 over 2 times 5. And so you'd get positive 4 and 10, and the square root, you'd end up minus 4 times 5 times 6 is negative 104. You cannot take the square root of that, so literally all you would do with this one is you would put an I and then positive 104. That's it. That's the only difference for now. We're going to learn a little bit more about that. This isn't even going to be on the test. Honestly, I will probably make it an extra credit question because I did spend a little bit of time on it. That's all you need to do. If you end up with a negative, really nice, that's great. If it doesn't reduce really nice, just put the I term. It doesn't make any difference, and that makes that square root into a positive. So, what this is, the whole punchline I did this. Maybe it's a mistake. Maybe I should have gotten into this. So if this is confusing, don't worry about it. The whole reason I went into this is the next thing we're going to do is I'm going to show you how you can tell whether you get one solution, like we did on the last one where you had 0, whether we get two solutions, like we have on all the other problems. The other option is two imaginary solutions. Instead of getting 0 solutions, you get 2 of them, but they're imaginary. This is what that would look like. So we have an I in there, so it's imaginary. We get 2 of them. We have 4 plus imaginary and 4 minus imaginary. So that's the options. We get 2 real, 1 real, or 2 imaginary. With 2 real, 1 real, or 0 real, and that's great. That's really good in Algebra 1. But in Algebra 2, I want you to know that if there's not any real answers, it means there's 2 imaginary answers. So, I'm going to go over this quick. I probably will go over the you-do questions, or I'll give you guys some time on them, but I'm not going to call anybody to save a little bit of time. The next thing we're learning only is if you not want to use the discriminant, if you think it's confusing, just use the quadratic formula and then look at your answers. Did you get 1 answer? Did you get 2 real answers? Or did you get 2 imaginary answers? You could use the quadratic formula for this. Not only the whole quadratic formula, I can find that are up. Note, the shortcut does not find the answer. It only finds how many answers. So I have some students that will do this and say, so the answer is 10. No, the answer is not what you're finding with this. It just tells you how many you find. And the next one, the next note, we don't actually even care what number you get. All we care about if it's positive, negative, or 0. So the whole reason we do this discriminant, we don't care what number the answer is. We only care if it's positive, negative, or 0. I like to say that before we even start. So if you look, the discriminant is b squared minus 4ac. I probably will not give that to you on your T sheet, and the main reason is because that's part of that formula. It's part that's inside the square root. Negative b squared minus 4ac over 2a. The discriminant is the part that's inside the square root. So if the discriminant is 2 real solutions, it doesn't matter if they're decimals or fractions or whatever. If they're positive, they're 2 real solutions. If it's negative, if it's 0, it's 1 real. Now, again, if you think about it, it makes sense because again, this is the square root of your quadratic formula. So if while you're doing quadratic formula, you end up with the square root of a positive number, well, yeah, that's going to give you 2. If the square root of a negative number, well, that's going to give you imaginary numbers. And if you end up, you're going to end up getting 1 answer, just like we did on that number 8 example. So again, that's why you can use this. That's why you have this little shortcut. If that doesn't make any sense, just trust me, baby birds. Okay. I mean, we don't even care what number we get as long as we know. That's funny. I copy and pasted note number 2 down here and forgot to delete it. So these questions will literally say how many and what type of solutions they are. Now I added that what type because I want to know, are they real solutions, are they imaginary solutions, so on and so forth. All you have to do is plug into that equation. B squared minus 4AC. There's no square roots, there's none of it. 5, so we have 5 squared minus 4 times A times B. That gives me 25. And again, you can just type that in your calculator, that's fine. But I just wanted to. We have 25 minus 8. 25 minus 8 is positive, 17. Since it is positive, your answer is 2 real solutions. I don't even care if it's 17, and that is not the answer to that. If I told you to solve this, the answer is not 17, not at all, not even close. But we're not trying to solve it, we're just trying to find how many answers there are. So 17 is positive, so that's your that gives you your answer. Now, a little shortcut to this, and I'd rather you guys not use this because, I mean, I'd rather you guys put it in your calculator. But one thing I've done in the past when I'm doing this, when I'm working on something, minus 8 is going to be positive, because 25 is bigger than 8. So you're going to have to find 17. I have students, and again, I wouldn't necessarily recommend this, but they don't find 17. All they do is they look at that and say, oh, it's got to be positive, so they just say that's equal to a positive, so it's too real. Because again, I don't care if it's 17 or not. All I care about if it's positive, so 25 minus 8, you know it has to be positive. Now again, I don't recommend that. I would just put it in a calculator if I were you, but to kind of stress the idea that we do not need the answer. Number 14, now again, just like the quadratic formula, you have to get it equal to 0. So that's 9x squared plus 6x plus 1. End up with your b is 6 squared, minus, now again, it's not plus or minus, because remember your formula. 4 times a times c. Whoops. 36 minus 36. Again, if you guys just put that in your calculator, honestly, that's what I would do. I just put this in my calculator. But I like to show you how it ends up equaling 0 or positive or negative. 36 minus 6 is 0, so that is 1 real solution. Now, do not get confused. A lot of students think that if it's 0, it is 0 solutions. 0 is always 1 solution. You never have 0 solutions. That means you have 2 imaginary solutions. And last but not least, get it equal to 0, 9x squared minus 3x plus 2. So we have negative 3 squared minus 4 times 9 times 2. That's positive 9 minus, 4 times 9 times 2. 72. Again, if you want to find out what this answer is, I personally would. It's not hard. 9 minus 72. And again, I would just put this step in my calculator, so find that out anyways. That gives you negative 63. But again, all we need to know that's negative. So that is 2 imaginary. If you say 0 real solutions, I'll definitely give you partial credit, but I want you guys to go one step further and realize they're imaginary. Now again, I do not recommend this, but if you just looked at this one, obviously 9 minus 72, 9 is way smaller than 72, so if you subtract 72 from 9, obviously it's a negative. So if you want to take that little shortcut, it's up to you, but again, personally, I'm just like to just run with that. And to show your work, write that step down, just like I want you to do the quadratic formula. Last but not least, did I record on this? Okay, cool. Last but not least, if you don't like the discriminant equation, or if you don't understand it, or if you think it's confusing, you can literally just type this into the quadratic formula and then look at your answers. So the quadratic formula actually gives you answers. But you just look at your answers and tell. If your answers look like the ones we did earlier, We get these two. Those are obviously two real numbers, -1/2 and -3/2. Those are obviously real answers. If you get an answer like we did earlier with 0, we had the square root of 0 over here, which means you just ended up with one answer. That's one answer. And if you end up with the square root of a negative, whoops, this highlighter works some of the times really well and other times it's terrible. If you get the square root of a negative, you end up getting an imaginary answer or two imaginary answers. Remember, you never have one imaginary answer. You always have at least two. Not learn about the number of imaginary. Oh, perfect. All right, so stop this.